Hello, my name is Raúl Santos. I work for Iberia, an SME in Madrid, Spain. In AIDOM, we are use case providers and solution providers. The use case that we propose is based on one of our products, which is called Tamus. Tamus is a solution for managing the restaurants, both from the hardware and software point of view, including aspects such as inventory, but also billing and the recipes and things like that. In AIDOM, we try to produce solutions to automate the production of the software, which has to be customized for each one of the individual customers. So this customization is very time-consuming, and we try to produce tools in AIDOM in order to ease on the process of customization, because we have a pretty small development team, and we have to produce the software for over 150 restaurants working throughout Spain. And it's not only the development, but also the operations of the restaurants, which is often, it's a day-to-day business. It opens 24/7 in some occasions, so we need to have people that are always on waiting for the restaurants to communicate issues and downtimes and things like this. So what we are going to present today is our solutions in AIDOM, which are centered around the 4 requirements that we defined for the solution. And the first requirement that we are going to comment is the requirement 02, which is related to the production of software that is able to automate the management of requirements. The requirements for our product are expressed in natural language by the product owners and the product developers. And so we are looking for solutions that enable us to understand the text in this natural language and processes, so we can, for example, categorize the requirements into different categories, such as, for example, front-end, back-end, or things like that, and also assign the requirements to developers that have been proficient in the past for each one of the activities. So what we are using is artificial intelligence. We take all of the text in the requirements, we generate some word embeddings with AI tools, and then we try to extract the semantics, the information from within. We use text CNN, which is a CNN model for classification, and using this we generate embeddings and from there categories for each one of the requirements. Then the requirements can be pushed back into the Trello board. This is where we store the requirements. So when you write down a requirement in natural language, it is automatically sent through the pipeline and then categorized and then assigned to a developer. And that's how we are trying to save time in the development of the solution. The other 3 requirements refer to the operation of the business. The business of restaurants is running 24/7 in some cases, so it's generating a lot of data that we can capture in order to detect issues or predict issues in some cases. So we started with a very basic thing, which is detecting the logs, the system logs that are generated, and we have a system that consumes the logs of all of the devices and all of the cloud systems that we are using, and then they are analyzed. This was done manually before the project, and now it is done automatically. And one of the things that we are targeting is to analyze the downtimes. Downtimes are very, very expensive in the restaurant business because people want to have their lunch or dinner or whatever all of the time. So all of the downtimes are very important for us to detect. So we have constructed an AI system that is able to detect the downtimes with some precision, and it's not only short downtimes, which would be like an on-off, but also more fine-tuning into detecting the downtimes that are produced. Then what we are doing in the requirement 3 and 4 is to analyze these downtimes in conjunction with the installation of updates. The system is updated periodically, so when the updates are installed, it is usually more likely that we will have these downtimes. So we are trying to analyze how the differences in each one of the updates is affecting the likelihood of downtimes happening. So we can see in another graph how we combine the downtimes with the installation of new versions of the system. And this is then fed into a CNN that we have developed in AIDOM. This is a custom development that is able to detect if the likelihood of the system failing or accepting the update without a downtime. So this is very simple, but we want to be able to predict when the system is more likely, when is it more risky to install an update. So we have run this system through an explainability framework, which is called SHAP. And with that, we have analyzed the different inputs that we have, which is the text of the update. For example, the change log of the changes or in features that we are applying in this update. Then also the date and time, which might be important because, of course, the restaurants operate also in Saturday nights, which are more intensive, but also in valley days, which are a bit quieter. So we thought that that was an interesting thing to introduce in the model. Also, the ID of the restaurant. Some restaurants are more active, some restaurants have different hardware configurations. And another thing that we also introduced is the statistics of updates and also of the system operation in the past, such as, for example, CPU usage in the past few weeks or days, or memory usage. So we introduce all of this data into the model, and with the explainability tool, we try to elicit what is the impact of each one of these things into the risk of the system having downtimes. And we detected that the features that are introduced in the update are the most important thing. They are a plus 0.4 in importance, but significantly with what we thought was intuitive, that the time of the update was important, we detected that this is a minus 0.3, and that means that the time when the updates are installed is not so important for the system. So with this, we have already an interactive tool that developers can use in order to detect the risk of installing a given update in a given time, and so we can integrate that into their workflow, and they can generate better operations in the update process in the system.